The first trend we're going to talk about is the cloud. And the cloud is changing the way we build, the way we deploy, the way we manage, the way we scale applications. It's really reducing the friction so that people and your teams can experiment with applications. At Microsoft, we had a couple of researchers who really wanted to understand the trends around Twitter. And so they built an application, and they built it, in this case, on the public cloud with Windows Azure. And as they built that application, they started to scale it so they could handle all of the feeds from Twitter. With just a few people, they were able to scale that application to 500 million updates a day, 15,000 storage requests every single second, 15 terabytes of new data every single month. And if you go back 5, 10 years before the advent of the public cloud, you can't imagine a team of 2 or 3 or 4 people building that kind of application. So the first thing we're going to talk about is the cloud. I'm having the same clicker thing, so I'm just going to try to click through here. The second trend I want to talk about is devices. So all of those cloud services that we're building, people want to be able to use those in a number of different devices. There's so much energy in the industry right now around new kinds of devices. People carry multiple devices, and they not only want those cloud services that they're building to work on their devices, whether it's a PC, whether it's a tablet, whether it's a phone, but they want that experience to be optimized. And so we'll spend some time talking about devices generally, and then some really unique applications of devices and sensors with respect to the cloud. So let's start with the cloud. So if you step back, let's talk a little bit about what's going on in the data center right now for customers. And probably the biggest trend over the last 10 years is that of virtualization. And if you look, there's about 20% of the servers out in people's data centers that are virtualized. And what you can conclude from that is that maybe we're very early on in this journey to virtualization. But actually, I think this stat really understates the impact that virtualization has had on the customer's data center. So let me give you some different ways to think about what's going on in the data centers. So if you look at the servers that have been shipped, as an industry worldwide, we ship a little fewer than 8 million servers every year. We crossed over an amazing threshold last year. We now create, if you will, more virtual servers, almost 11 million, 11 million virtual servers over the 8 million physical servers. So we now ship more virtual servers than we do physical servers. And that's going to even become a broader trend as we think about the installed base. So there's about 28 million or so servers in the installed base worldwide. This year we're going to cross over, and we're going to have more virtual servers in the installed base than physical servers. And in that world, clearly what happens in the data center changes. The way we manage physical and virtual environments has to change given how much the environment has become virtual. One of the questions I get asked often is, does this mean that we are going as an industry to be having less servers? Are customers going to be buying less servers? And the answer is no. We continue to have robust double-digit growth in servers, and if you look at the projections out for a number of years, it'll continue to be robust growth. So what's happening is that the business still is demanding more and more automation, more and more digitization of the business, and then we, as an industry, are using virtualization as a technique to manage all of that influx of capacity. Now, all of this virtualization has been happening for a number of years. But really, this is setting us up for a much bigger trend in computing, and that is this trend toward cloud computing, both public and private. Taking all of those virtual servers and then managing them in a holistic way, dynamically being able to get resources, scale those resources based on what's going on with the users, contract if necessary, and manage things in a completely new way. It builds on virtualization, but virtualization is only a building block. There's many other components that come into cloud computing. When I talk to customers, there's really 3 themes that emerge about what's driving cloud computing: agility, focus, and economics. Let me talk briefly about each. So agility is about being able to get that application out quickly, like the researchers that wanted to do Twitter, and then being able to scale that application in a very, very easy way, either scaling it up or scaling it down. The data center and the infrastructure is interesting in that it is critically hard to get right. But after you work it and you get it right, it doesn't fundamentally differentiate the business. The differentiation comes from the higher level software that uniquely has business insight for that business. So it's hard to get right, but it doesn't differentiate. And so cloud computing, whether it's private cloud, helping the business units not focus on the infrastructure, or if it's public cloud and letting the entire IT organization not think about the infrastructure, it allows you to focus on things that actually, at the end of the day, differentiate the business. And then finally, economics is another massive driver. If you look at the delta, the cost per server between a large private cloud, so call that 1,000 servers, and to give you a sense, there's only 1,000 organizations in the world that have 1,000 servers in their installed base, and we're talking about 1,000 servers in a particular data center in a particular cloud. So you compare the cost per server of 1,000 servers in a private cloud, a large private cloud, and then you compare the cost per server in a large public cloud. That might be 100,000 servers. If you look at those costs over the next 10 years, we think there's an opportunity to save as much as 10x between private cloud and public cloud because of economies of scale and because of increased utilization. And that 10x is on line items, budget items, both in capital expenditures and operating expenditures, which are some of the biggest in your budgets. So this really could change the landscape of IT as you think about the agility, the focus, and then these massive economic drivers. Now, does this mean that we're going to flip to public cloud computing overnight? And the answer is clearly no. There are real obstacles to public cloud computing for certain industries, for certain geographies. If you look at any customer survey over the last 12 or 18 months, 3 themes emerge very prominently, consistently across those: security, compliance, and compatibility. People have compliance issues, data regulation issues, regulatory environments, sovereignty with respect to government data that really have to be addressed. And there's compatibility, both taking your existing assets and moving them to the public cloud, but also integrating with all of those existing systems. These are things that have to be worked out over time. And so some of these things are going to be resolved relatively quickly, but a lot of these things are fairly deep, and it'll take both the medium to long term to go through. So when we look at the drivers, which are very, very compelling, and we look at these obstacles, which are also relatively deep, our conclusion for customers in terms of the strategy, and then us as a vendor in terms of how we provide platforms, is that you really need to focus on both private cloud and public cloud. And so let me talk a little bit about our investments in both of those areas. In the public cloud, we have a broad platform, Windows Azure, and that includes both our operating system capabilities and our database capabilities. And then on top of Windows Azure, this broad platform, we have a wide range of workloads. So we have Office 365, which is our productivity suite. We have Dynamics, which provides CRM. Windows Intune, which provides management and security as a service for desktops. And then, of course, third-party applications, ISVs, and businesses and enterprises building applications on top of this platform. And this is great in terms of agility and focus and economics when the public cloud makes sense. But for those cases where you can't take advantage of the public cloud, we've also invested heavily in our private cloud. And our private cloud starts with Windows Server and System Center. It provides the foundation, an elastic foundation for the workloads that people need to run. All of the capabilities that exist in our public cloud that will run on your behalf, we also make available as servers that you can run in your private cloud. And so things like Lync and Exchange, SharePoint, which is part of the Office 365 set of capabilities, SQL Server, which is part of the core Windows Azure platform, Dynamics, and then, of course, third-party applications as well. Now, the key to this strategy is not just that we're going to invest in the public cloud and that we're going to invest in the private cloud. That's the key baseline. The strategy, though, is to make sure there's enough commonality so that people can start in the private cloud and, as appropriate, move to the public cloud, and vice versa, start in the public cloud and then, for whatever reason, want to move to the private cloud, and have hybrid applications where part of the application runs in the private cloud and part of the applications run in the public cloud. And we have large customers that are doing all 3 of those. And so we are focused on commonality, which for identity, for virtualization, for management, and for development. And so making sure that the identities, for example, that you have in things like Active Directory in your data centers today can be federated with the public cloud, with applications from Microsoft and third-party applications. Virtualization, you can have a virtual machine in your private cloud, and you can move that to your public cloud and vice versa. Management tools work across both public and private. Development tools work across both public and private. So this is kind of the key strategy that we're taking based on both the compelling economic and the obstacles that customers face, letting them decide how fast they want to move to the public cloud and how much they want to invest in the private cloud. Now, across all of this, one of the key parts of what we think we have to do to be successful is to have this be a very open platform. Oh, before I go on to that, let me give you a sense. So we've been in the operating system business for a while now. Windows Server powers about 3/4 of the world's servers. We think about Windows Azure and that public cloud platform as the next generation operating system. So Windows Server is a server operating system. We think about Windows Azure as a cloud operating system. We built Windows Server for a form factor of a server. We are building Windows Azure for the form factor of thousands of servers in a data center across multiple data centers, across multiple geographies. And if you look at the investments that we're making in Windows Azure, it looks like the same set of capabilities that you might see in a broad end-to-end operating system. Compute, storage, core networking, core identity and security, higher level services like the web, messaging, workflow, content delivery. In the case of the public cloud, we think there's an opportunity to bring together both storage and structured and unstructured data, so kind of the database capabilities, but do that in a very seamless way in the public cloud. So bringing those categories of software, the operating system and the database together within the Windows Azure platform. And then if it's an operating system, it needs a broad ecosystem. It needs development tools. It needs management tools. In this day and age, it needs a marketplace. So we're investing in all of those things to make sure that we have that broad operating system view of this new public cloud. So when we think about how we're investing in the cloud operating system, the public cloud, and how we're investing in the private cloud with Windows Server and System Center, core to being successful in that is to make sure that we have an open platform. And so you can think about our commitment to this level of openness and interoperability on a number of different levels. Tools. We have a tool in Visual Studio that a lot of people use. It's very popular. But we want to make sure that we support other tools, whether it's command line tools, open source tools, the Eclipse tool with Java and other plugins. We want to make sure those are first-class experiences, both as they have been historically with Windows Server, but also as we move forward with things like Windows Azure. Languages, .NET, Java, PHP, Ruby, whatever you want to develop in, we want to support that, both in the private cloud and in the public cloud. And then protocols, making sure that everything we do in the public cloud is available as a set of APIs on HTTP over REST that you can access from any programming language, from any environment, really making interoperability real. And to really kind of bring this to life and show you what you can do with a very interoperable system, I want to bring out John Shuchuk, and he's going to show you some of these things as a demo.
Thanks, Bob.
Thanks.
So, like many of you, as I came out, I used a travel website to put together my trip here. So I wanted to spend a minute or two just kind of talking about an application that we put together called Margie's Travel, which illustrates some of the principles that we've been talking about. So let's take a look over here at Margie's Travel. Margie's Travel is a pretty sophisticated application. We've got a website. That website is talking to back-end databases. It's integrating with National Weather Service data. It's talking to transactional ticketing systems, mapping information. There's a lot going on in these modern apps. Now, we happen to be talking about a customer-facing app, but this could just as easily be a business-to-business partner app, or it could be an internal app. And as you build out these kind of apps, you've got to think about interoperability and how all the pieces are going to fit together. Now, you'll notice I'm using Google Chrome to access the app because it's a web application and because we're using the HTML standards, RSS, and other technologies. we're able to just project that information to many different kinds of devices. So as you can see here, Chrome's providing that experience, but in many cases, people are thinking about mobile devices, and we might want to be able to bring down a mobile application, whether that be on our Android device, on our iPhones, on the new Windows phones, or even Windows 8. So what I wanted to do is spend a minute or two looking at this application and take a look at what the experience might be like on Windows 8. So let's switch over to the new Windows 8 Start menu, and as you can see, there's a collection of Metro user interface tiles, and here we've got Margie's Travel, and if I start that up, Margie's Travel, the app starts, and notice that Margie's Travel wants an identity. They're going to use identity to glue together the many, many different parts of this application. Now, when I started using Margie's Travel, I started up on the web. I used my Facebook identity to log in. Now, I could go create another kind of identity. I could go create a username and a password, but I already have hundreds of those things. Why do I want another one that I'm promptly going to forget? And for many organizations, creating and managing those passwords ends up being one of their top support calls. So because Margie's Travel happens to be built using Windows Azure, one of the key things that we get is we get the ability to integrate with many different identity systems. So what's going on here is when I clicked Login, I actually communicated up to Windows Azure, and Windows Azure was configured to be able to interoperate with many different identity providers. In this case, we can see it's using Google identities or Facebook identities. It can use Windows Live IDs or even your corporate identities. And this ends up being very important because this reduces the effort for your users to go integrate with your application. You could, for Margie's Travel, for example, the ability to, say, integrate with Boeing's corporate identities is a big deal because that means that they can use the same identities that the customer is familiar with. In this case, I'm going to log in with that same Facebook identity that I used when I went up on the web. And as you can see, we're using the new experience that Windows 8 provides to provide a consistent login experience. So I'm going to use my Facebook ID and type in the password. And that's going to complete the login. What's really going on there is we're working together with Windows 8 and Windows Azure to connect us up, and now we've logged in and we've accessed that same information up on the server. Now think about the challenge that your developers will have creating applications like this. If you think about just the website and you want to talk to all of these different kinds of identity providers, they use a lot of different protocols. And in many cases, those protocols are proprietary. So you want to get all of these different identities working just on the website, but then you think about, well, I got to get it working on iOS, I got to get it working on Android, I've got to get it working on all of these other platforms. So you start looking at all of the code that's going to be involved in just getting the identity part to interoperate, and it can be thousands of lines of pretty complicated code. Now the exciting part about this, and let's just take a quick look at the code. I'm not really going to go through this in detail. Let's switch over to the desktop, and I'm going to bring up Visual Studio. You can see what's going on just in this one line. We're actually contacting Windows Azure, and we're asking it for a list of the identity providers. It turns out, if we were to look through this app, there's about 4 similarly complicated lines of code where we go get the list of identity providers, we then present that list to the users as you saw in the application, we go talk to that identity provider in conjunction with Windows Azure, we get a token back, and we're off and running. So it really reduces the complexity of using identity in one of these mobile devices or up on the web. So from your developer's perspective, big, big, big savings, tons of interoperability. It also has a lot of benefits for your user. Now, I could show you on this same machine logging in again, and I would get single sign-on to this application. It would remember. But Windows 8 actually has a pretty cool feature. Imagine that you're running to the airport, you've entered your flight information up on the web, you've been working on your Windows 8 PC at work, and now you've got all those bags on, and you go to your tablet and you want to go look at the website. and you want to get your travel information. You don't really want to be typing in that password one-handed as you're going through the airport. So let's switch over to another Windows 8 machine. And this is my laptop as I'm running through the airport. And notice I click on it, single sign-on. An amazing thing happened. Because these are all connected together with my Windows ID that's connecting my Windows 8 machines, my identity flowed across to this other machine, and I got single sign-on on all of my devices. So that integration provides a seamless experience. Now, there's another pretty interesting thing that's going on if you kind of step back and think about what just happened in this app. I started up on a website. I used my Facebook identity. That Facebook identity served as the glue to connect the data sources behind that application to the data that's being used within the application. I then went to my work PC where I was using Windows 8 or perhaps an iOS device, and I used that same Facebook identity. Those credentials then flowed across to all of my other devices, and I got single sign-on across those machines. That same identity system is actually being used internal to the application. Let's go take a look at, for example, an upcoming trip I have to Maui. What you see here is a collection of a lot of different data. We've got data from the National Weather Service. We've got information from Bing about advertising. We've got analytics that are being taken from organizations like Wolfram Alpha. All of those back-end data sources use the same common underlying data system, technologies such as the OAuth protocol, to enable that information to be collected together up on Windows Azure and pulled together to produce this experience. Now, another key aspect of this is, as you can see, I just was upgraded. I got a notification. What happened there was Windows Azure and the Microsoft Cloud were able to establish a secure connection down to this application and provide notifications to the users so that late-breaking information such as seat upgrades or news or stock changes can be seamlessly integrated into that application experience. And so what we're seeing here is a combination of interoperability, Windows 8, and Windows Azure working together to provide new kinds of experiences that we think your users are going to love. Thanks very much.
So that's a brief view on the cloud. Let's now turn to devices. The thing that's amazing about devices right now is how much energy there is in the industry. And if you look, in the US right now, people have on average more than 4 devices per person. And that's an average. My guess is in this room it's probably 7, 8, 9, 10 devices. We crossed over another amazing milestone. I talked about the crossing over in terms of shipments of physical machines to virtual machines. We also crossed over this other amazing milestone where we are now shipping more smartphones than we are PCs as an industry worldwide. And the growth in those smartphones continues incredible growth at 81%. And when you think about devices, I challenge you to broaden how you think about those, not just in phones, not just in tablets, not just in PCs, but really all of the sensors that are available, all of the gaming consoles. In the US, people have an average of 1.5 game consoles. And things like the Kinect, which bring motion, which is one of the fastest, actually the fastest selling consumer electronics device in history. So there's all these new kinds of devices and new ways to interact with these cloud services. And to give you an example of something that's much more unusual than what you'd expect from a phone or a tablet, I'd like to invite out Brian Goldfarb, and I'll show you something very interesting. Thanks, Brian.
If I can have that. New innovation in devices in the cloud are enabling us to do new scenarios in ways we never before thought possible. Now, what we're going to see today is how we can use cloud-connected athletics to change the way we have safety in sports. Some context, though. Every day, athletes suffer sports-related head traumas. Sometimes these traumas can result in injury or death. To put that in perspective, the CDC estimates that there'll be 4 million head traumas this year from sports-related injuries. 80% of those will go unnoticed or unmanaged. Over 5,000 concussions will occur this week in high school and collegiate athletics. And we don't even know how many will happen to our youngest athletes. And this isn't just football. Hockey, lacrosse, rugby, soccer are all sports where we see these head traumas. It turns out that women's soccer has the highest concussion rate per player in the world. The good news is we're helping solve these. There are companies out there that are helping solve these problems through technology. Now, X2 Impact, a local Seattle company, has created a revolutionary new mouthguard technology that harnesses the computational, analytical, and storage capabilities of Windows Azure to create cloud-connected athletes. Now, the beauty of how this works is in its simplicity. Athletes simply wear this mouthguard, which acts as a sensor that collects real-time impact data about what's happening on the field, as you see on the screen behind me. Once this data is collected, it's sent to Windows Azure, where we look at historical data, concussive models, to help determine any potential health risks to the athlete. Now, what we're seeing here happen is that these devices are talking to a base station, sending data up to the cloud, where we can store all that information in perpetuity for later research and analytics. Now, once that processing happens, which happens almost instantaneously, the information is sent to the sideline where coaches and trainers have access to an application. Now, we'll take a quick look at. In that application, we can see player impact data in real time. All of this information looks at aggregate concussive information. We can see daily and weekly reports. And I, as the coach or the trainer on the field, can analyze which of my athletes has potential issues. I can create watch lists that I can use to take track of players. I have assessment information that I can leverage to help identify any potential concussive risk and pull those players off the field if we see there's any problems. Now, by using Windows Azure, we are able to take advantage of the fact that we have push notifications. And I can instantaneously update a device like a phone or a tablet so that instead of having to watch the application, I can focus on the game. Even parents in the stands now can get notified if their son or daughter has a potential injury. Now, what's great about this is X2 is bringing this to market next year through their relationship with BikeGuard, who's the exclusive supplier of this technology for Under Armour. Now, what's great with X2 is they're using creative new thinking in devices and cloud services to change the way we keep athletes safe. Now, with Windows Azure, we all have the power to do the same thing and create new big ideas and take on everyday complex challenges. Thank you.
Good job. So it's really amazing the possibilities of bringing together cloud services and then these different kinds of devices, both maybe conventional devices like tablets and phones and PCs, but then these sensors and these other kinds of very unique devices. It's a very interesting time to be in our industry. I would say that we are reinventing how people build applications with the cloud, and that's both private and public cloud, and how we deliver and how we scale those applications, and how quickly we can experiment and innovate in that space. And we're changing the way people interact with those applications. Being able to take a tablet and put it into a classroom setting, being able to have that phone anywhere, anytime, and interacting with that. It really is opening up incredible possibilities. And then there's things like BikeGuard, which is really pushing the frontier on how we think about where software can play in our lives. So very interesting things. And all of these things really have at their core, and the glue is interoperability. Because the expectations from users continues to increase. They want that device to work on whatever, they want that service, to work on whatever device they choose, whenever they choose it. So whether it's a tablet, whether it's a phone, they want to make sure that works. If they're a developer, they want to be able to use the language of their choice to interact with those services. They want to use their identities in the demo that John gave and bring those identities to whatever website they're interacting with. So making sure that the industry has this commitment to having the interoperability work really unleashes some of the innovation that we as an industry can get from this revolution in both the cloud and in devices. I hope you have a great conference. Thank you very much.